Hello, this is a short video to show how you would go about creating a blockchain network, generate an API, and also associate a data store for your blockchain transactions using the Simba platform. So I'm going to just log in. We use Auth0 for authentication, and I'm going to sign up with a new user here, which I'm going to call a user. Click sign up and that's going to launch me into the platform, and this is the Simba dashboard. Now when I log into the platform for the first time, before I can do anything, it's going to ask me to specify an organization. So I'm going to call my organization Simba, and then so I've got an organization. Within an organization I can have multiple applications, and within applications I can choose to associate groups or users with that. So here I haven't entered a name yet, so if I go to my profile, I can add my name, Ian Taylor, update, and that will make it seem like more my account here. And then I'm going to add a new application. So this application I'm just going to call a card demo, and you need to an application needs to live in an organization. So I'm going to select Simba there. So I've got my card demo, and I can look into that, and it's not configured at the moment. So let's go ahead and add some users. So first of all, within an application, you can specify a group. So I'm going to call a group DevOps, and I'm going to associate that with the card demo. So create, and then once I've got a group within application and organization, I can then add users. So if I add users, I can add myself, for example, as in the DevOps teams within the particular application. And you can just add other users. Andrew Jones, who's also part of the DevOps. Okay, so I have users and groups, and now let's configure my application. So I'm going to go to Applications, click More Info, and this screen basically takes you through the various stages. So the first stage is to select a particular blockchain you want. Right now we support Ethereum. Hyperledger Fabric is coming shortly. And then within Ethereum there's multiple different networks that we support. So Ropsten or Ringp or a test network. So I'm going to select Ringp and click Config there. Now that's configured the blockchain network here with a particular ID. So this is going to work with Ethereum. The way we transact on the blockchain is the smart contract will allow any number of parameters to be added, which will be recorded onto the blockchain. And then if you attach files alongside the transaction, then that's automatically put into a data store. So IPFS or Ceph here. I'm going to choose IPFS. So the data is put into the store, a hash is generated, and the hash is added to the transaction on the blockchain to bind them to. And then the third step is to create a smart contract. This is Ethereum, so this is Solidity code. And this is just a very simple example just to get you started. So this just registers a car, registers an accident report for a car, and then a sale for a car. So I'm going to click use there. So I've got thumbs up on all of these. And then the final thing is I'm going to call the name of my application and click deploy. And that will create an application configured for the use of Ethereum and with a particular data store. Now let me sign out and sign back in as a separate user, which to go into an example that basically is filled out more. So I'm going to click not your account, and then a test user has a number of applications already configured. So let's go into that account and look at the applications. And one of which is a car demo, which is kind of similar to what we just created, but this is actually a little bit more fleshed out. So if we look at that, the smart contract is parsed, and we generate a JSON schema from that smart contract, which basically specifies the types of transactions and assets you want to store, along with the parameters. So we automatically generate a REST API for that particular application, and we can see that by clicking this car demo link here. And this is using Swagger to document the API, but this API is basically generated from that smart contract. So we have a post for a car sale. If we want to post a car, to register a car, we have a post on the registered car, which can add things like VIN and make, and then the bundle hash is is the hash to the external data. Now the external data in this case could be like photos of the car, for example, and so forth. So basically what is being generated here is an API that you can use and build front-end applications for the assets, in this case cars and transactions, and you can pretty much get going and write the application against this particular API very quickly. In order to post a transaction using the smart contract here, the JSON schema generates this UI, which allows you to call methods and choose a particular file. So let me register a car using the register car method and choose an image on my desktop, our demo picture, open. Okay, so once I do that, I can upload this into the system, and that's basically stored that image into IPFS for this particular configuration, and it's generated a bundle hash. Now the function, I'm going to put a model, Toyota, then I don't know what that would be, but something like that, Toyota, and then attach the bundle hash. So basically what this is doing in this kind of somewhat simple form is making a method call on the smart contract with these car details, and it's associating this bundle hash to a picture of the car also. So we've uploaded that, so let's call this. This is being called on the Ethereum test network. This will take 30 seconds or so to kind of generate, but once it's generated, we should be able to verify this transaction and take a look at the data. Transaction has been made. Okay, let's take a look at the transaction. So I'm going to click the list of the transactions here, and so let's look at the last transaction, which would be the one that I've just done. And if I get the bundle for that particular hash, then it retrieves the image, and this is the car demo picture that I just uploaded. That was a fairly quick overview of the system, but I hope it kind of relayed the point.